Let's look at an example of actually putting a lot of this information into use. So let's say that we encounter a particular line and we're asked certain questions like find the slope or write an equation for the line. And one other formula I wanted to review that was not in the slides is ways to calculate the slope, which are different ways it can be taught. So I thought I'd just kind of review those ways. One way is by referring to the rise over the run, as I did in the past video. But a lot of times it's written in a formulaic sense using the notation delta y divided by delta x, which is just a way of saying how much has y changed and how much has x changed between 2 points. Or formulaically, we'd write that as y2 minus y1 over x2 minus x1. And I'm sure you've seen this formula before, but I just thought I'd mention, how I might be doing it in these videos. One second, I need to log into my iPad. Okay, here we go. So I can write on the whiteboard here. So if we were to find the slope, we could do it any way. How I would typically do it would be just by looking at the 2 points, or you could also just pick any 2 points along the line. But if you're given to, it's kind of like, well, here's some specific ones that are easier because you know exactly what they are. And basically, I could find the slope just by examining, well, how much has it, what's the change in the y and what's the change in the x between these 2 points. So what I can see is that the change in y, it has risen 1, or technically it's fallen 1, and it's run by, it appears to be from 2 to 5, which is 3. And so if you take that fraction 1/3, that should be the rise. But one other thing that I wanted to mention about how do you know whether the slope should be negative or positive, and what I said was that if the line is going down to the right, it should be negative. But technically, the slope is a measurement of how much the line is changing from left to right. So if I'm starting on the left point, notice that this is not a rise, it's really a fall. So the rises should be negative because I'm actually going downward, and the run should be positive 3. Now, technically, it doesn't matter which way you go, if you were wondering, because if I start from the right-hand side, technically I'm going to the left 3, which is negative, and up 1, which would still be negative to positive ratio. So at the end of the day, the slope will be equal to negative 1/3. And it doesn't matter whether the negative's on the top or the bottom of a fraction, because either way it makes a, the net fraction is negative. Anyways, but you could also, so that, that would just be equal to the rise of a run, but that should be the same as if I were to use the formula, which is equal to y2 minus y1 over x2 minus x1. And also the order that you use does not matter. It could be y1 minus y2 as long as the points are consistently first and second in order. And typically we let x1, y1 be the left point and x2, y2 be the right point. But again, it doesn't actually matter as long as you're consistent with where the point is in the formula. So we would have y2 is 2 minus y1 is 3 over x2 is 5 minus x1 is 2. And notice we'd wind up with exactly the same thing. It's just that it's a formula which calculates the quantity, which is a slope. And hopefully you can see why that makes sense. Y2 minus y1 takes the difference between this and this, 3 minus 2, and that's how we can figure out negative 1. Or really, it's 2 minus 3, I mean. And x2 minus x1 takes, x2 minus x1 takes the difference, which is just this amount. So formula for calculating exactly that. And now, next we're asked to write an equation for the line and asked, is it a function? Well, we know it's a function because of the vertical line test, and as I said, all lines are functions unless they're vertical. But basically, we could we could try to figure out, well, what is the function value? And just to recap, that slope-intercept form is typically how we write our function for the linear equation because it's solved for y. And then when we replace y with f of x, it just is a function and it's naturally going to be in slope-intercept form. But if I want to write the equation, as I said in the last video, we want to start with the point-slope form because notice that we actually don't know the y-intercept. We could look at the graph and say, well, it looks like maybe it's 3.6 or 3.7 or something, but that's not very exact. I mean, when we're writing an equation, we want it to be exact ideally. And since we know 2 points, we don't need to bother worrying about the y-intercept because, well, I know 2 points, which is actually more information. I only need to know 1 point and the slope. And if I go ahead and plug that in, I could start with the point slope form for a line, and then plug in x1, y1, which, as I said in the last one, it doesn't matter which one is x1, y1, as long as you just pick 1 point. So let's just go ahead and be consistent. We'll use 2, 3. So 3 would be our y1, and 2 would be our x1. And m, as we figured out from step 1, is -1/3. And so we're left with basically now we have an equation, and technically this is an answer. We can just stop there. But usually, if this was something your teacher for algebra emphasized, usually we're going to try to simplify this and clean this up a little bit, or really just change it, write it in slope-intercept form. And really, all that we need to do is isolate y, or basically add y1 to the other side. So an alternate form sometimes you'll see for point slope form is y is equal to mx minus x1 plus y1, which is just basically a functional way of writing the point slope form as a function. So basically, add 3 to both sides, and that would give me a function. And what I could do is then multiply this all out and simplify it out, right? Because if I apply the distributive property, I would get -1/3 x. And remember, if I'm multiplying here, -1/3 would distribute to both terms, which would give me +2/3 plus 3. And then I could add the fraction to the whole number. 3 would amount to 9/3, plus 2/3 should be 11/3. So that would leave me with the function -1/3 x plus 11/3. And there we would have it. And I could also check my work by going into my calculator and graphing the function, the answer that I've gotten. So I came up with -1/3 x plus 11/3, and I could see that it makes the same equation or graph that I was given here. It looks a little different because of the scaling of the axes, right? Notice that the domain and range of my graph here is a little different than what's showing in my calculator. But another way you could actually, if you wanted to check to see if these 2 points are on this line, you can use the trace feature right here on your calculator to actually go to specific points. And I want to show you real quick how to do that. So if you click trace, you'll notice that it starts off at the y-intercept. And I could check to make sure that makes sense with my formula, which 11/3 is equal to 3.6 repeating yes. So that is good. And one way I can check, but that should be the case because I literally just typed this in, so it should have that y-intercept, right? But if I actually just type in 2 and hit enter, what it will do is it'll move to the x location of 2. So basically you can move around and trace along your curve by hitting trace and then just typing in your desired x value. So notice I get the point 2, 3, and then if I just trace and hit 5, notice I get 5, 2, and I can really quickly confirm that yes, this is good. This function is the correct equation for the line.